Persons and unpersons, welcome back to the old computer shack. It is Tandy the 2nd, and tonight I think it would be pretty rad to try to fix this TRS-80 Model 4. I'd said previously that I was getting a raster on the screen, but nothing else was happening. Apparently the gremlins have been crawling around in here because it's acting completely different now, which is actually kind of bad. If the high voltage section is out, we're kind of fucked because I'm not an analog guy. But if we're very lucky, maybe it's just power supplies. We'll take a look at it and see, but here's what it's doing now. I cut the power on. The disk drive motor runs for a little bit. I'm not sure if you heard that or not, but I don't get a raster on the screen anymore. No matter where I put these contrast and brightness controls, I don't get any raster. I'm sure that on every other channel that you've ever watched where they talk about opening up CRTs, they have all said the same boring shit about safety, but I don't want to get sued, so keep in mind that there are high voltages inside of these machines that have cathode ray tubes, and one must be very careful when working inside of these and take appropriate safety precautions. Now, the way that we're going to remain safe, this is specifically for Al at Al's Geek Lab because he keeps making fun of all of my beer cans. But see, alcohol has a lower conductance than blood. So, obviously, the safest way to work on CRT monitors is to fill yourself with liquor until you have replaced your blood with alcohol. And then you can electrocute yourself all day and not feel a thing. I know this from experience. So, obviously I'm being completely facetious here. Don't do that. If you are dumb enough to actually do that, then do it and you deserve what you get. Okay, let's continue now. Back into character. Alright, let's open it up. See, this is weird, man. Like, I was telling him the other day in a comment, like, the layers of irony behind this YouTube persona have become so thick that I can't tell the, like, what's real from what isn't anymore. It's like postmodernism or something. Like, everyone loves watching people act like clowns, right? But as time passes, I find that it's getting harder and harder for me to figure out where the line between the amusing YouTube character and the actual high-functioning alcoholic is. But I digress. Let's, maybe I'm not all that high-functioning. Let's take this thing apart and, see if I can turn my fingernails black. Yeah! Alright, so this is the bottom of the machine. I'm getting ready to take the screws out here, and, it's too big. I mean, the thing's gigantic. I can't fit it all on the camera without backing up across to the other side of the room. And there are a couple of different versions of the TRS-80 Model 4. There's what they call a gate array version and a non-gate array version. Now, the non-gate array version is the older version. And you can tell which is which because the serial port on the non-gate array version, which is what this is on the bottom. And in the gate array version, it's in the back here. It's a lot easier to get to. The gate array version's the later version. They replaced a lot of the discrete logic, according to my understanding. I've never actually looked in one of these before. This is my first time on a TRS-80 Model 4 version. But they replaced a lot of the discrete logic in the non-gate array version, like this one, with like PLDs and shit in the gate array version, which actually means that this one may be a little easier to fix than the Gatorade version, because we're just dealing with discrete logic and we don't have to figure out what any PAL equations are or anything like that. However, I think all of those PAL equations are on the internet. There's a guy named Pete Sapinski or something like that, that's like the total TRS-80 guy, and he's got all that stuff on a website somewhere. So you know, you can burn new gals and shit if you have to, but still. Anyway, alright, I've got all the screws out of the bottom. It's exactly the same as the DT1 was. So, you know, I'm not going to document that because boring, right? But anyway, so apparently, I've never had one of these apart before, but apparently, unlike the DT1, so there's some wires and shit in the back around the neck of the CRT. I mean, not like around it, but near it. And it's very easy to snag the neck of the CRT on those wires that are attached to the bottom part of the computer and break the neck off of the CRT when you lift this thing off. So according to what I've read, hopefully we won't terminate this project early by tearing something up here, but according to what I've read, what you're supposed to do is like lift it off a little bit and then look into the crack up here above this disk drive and make sure that your wires aren't snagging shit back there. So there's no way that I can get that on camera, so I'm gonna do that and then I'll be back. Alright, I'm full of shit. There's actually a one little screw in the back that needs to come out as well. So yeah, it's apart now, and there's the distinct odor of burned stuff in here, and looking in here in the in this power supply, let me see if I can zoom you in a hair. Maybe. Can you see from here? Where are you? Ah, here they are. So on the other side of this fuse, you can't see them very well, I don't think, but there are a couple of X2 refa capacitors here. Those are just AC line filter capacitors. They're actually unnecessary, but they are both in really bad shape, and that's probably where the stink is coming from. So these things are supposed to have two power supplies in them, I thought, unless I read the wrong stuff, but I think this power supply is for the disk drives, so the one for the logic board, I guess, is back there somewhere. So alright, so I've got the power on, and we ought to be able to see a glow from the back of this CRT here, where the heater filaments are, and there is nothing there. So yeah, we're not getting any we're not even getting any heater voltage. It's not just that we're not getting any high voltage flyback up there. We're not getting any heater voltage either, and that actually leads me to think that it's probably more likely a main power supply issue than something with the flyback on this board here. So that's good, because I'm not very good at fixing that kind of thing. And this thing is just so big, there's no good way to film the thing. Alright, so I took this RF shield off of the back, and I don't see any other power supply in this thing, which is a little worrisome. However, this was unplugged from the logic board for some reason or another. Do not understand. And I think I'll check the voltage on this and see what it is, and if everything looks normal, I'll plug this in and see what happens. It's very weird. I wonder if this was the problem the whole time. I mean, at least when I was getting a raster, there might have been no power to the logic board at all. Although this looks like power over here. I don't know what's going on. Let me get my meter. We'll check this thing out. We'll just ground on the chassis here. That should be fine. And got a little bit of transient voltage there, but that's alright. That's just millivolts there. I hope you're watching in 1080p. Alright, so I'm going to guess that the red wire is going to be 5 volts. Okay, I'm going to guess the brown one's going to be, okay, that's negative 12, negative 11. That's a little bit low. No, that's negative 11 millivolts. So that's probably the ground. The orange one's probably 12 volts, and this is probably negative 12 volts on the yellow one. No, that's 0.6 volts. I wonder what the yellow one's supposed to be. Why do we have two? Well, if that's supposed to be negative 12 volts, part of the power supply might be bad, but you'd think the logic board, other than the serial port, would need nothing other than 5 volts, unless it's got shitty old RAM that requires 12 volts or something. I don't know. I'm gonna plug that in if I can get it turned off without bumping the camera, and see. Cramping my neck. See what happens. Alright, let's hit this bad boy and be ready to turn it off fast if chips start explodifying. The voltages are staying the same. The disk drive is continuing to run though. So, by the way, this little connector over here that I was checking voltages on and screwing around with, it actually just goes to a speaker board. So I guess they just used the same cables, even though that's a little strange, you know, color coding wise, but alright, whatever. Lucky us, it looks like this power supply's got the voltages of what's supposed to be what printed on here. So let's power this thing up and see what the voltages are with it loaded, and then try to unload it. So we'll just ground on the frame over here like we did before, and check these. So this should be a ground. Okay, it reads as a ground. You can't see my meter from here, but oh well. Now V2 is supposed to be 12 volts, and it reads nothing. We got no 12 volt output from the power supply. Okay, so then there's a key. V4 is supposed to be negative 12 volts. That's the yellow wire, and it is 12.42 volts. Okay, the orange one, V3, is supposed to be positive 12 volts. Yes, okay, 12 volts. Come on. 12 volts. Okay, now the red one is V1. That's supposed to be 5 volts. Okay. 4.76. Oh, come on. Slipped off of me. 4.76, okay, and the rest of these are supposed to be ground. I've got a little bit of a voltage transient on here, but it's nothing to worry about. It's like 25 millivolts. That's nothing. So V2 on this connector right here, this is supposed to be 12 volts on this orange wire. And where does that go? That orange wire goes down to the CRT connector. Well, gentlemen, gentle persons, gentle unpersons, perhaps we have found the source of all of this ghastly stuff thing here. Okay. Shush, disk drive. Jeez. Let's make sure this is the correct wire. Just to be sure, this orange wire right here, this one right here, coming up through this harness, this one right here, It is that one. It doesn't have 12 volts on it. Alright. Perhaps the next devoir of business is to unplug the shit and see what we get. I rhymed. And I guess that's good enough. Okay, come hither, sither. Alright. Yeah, there's definitely nothing on that pin that is supposed to be reading 12 volts. It's like exactly 0 millivolts. Hell, I have more transient voltage on the fucking ground. Yeah, I know it's turned on. My meter's bitching because it's been on too long. Well, that's interesting. Since the disk drive is running now, like, okay, check this out. All right. So the disk drive is running. Sorry about all the noise. I've got you on a stick. So the disk drive is running, right? Now I've got this old disk in here. If I put the disk in, there's no like head seeking and shit, but that may just be a bad disk drive. But then, okay, if I open it and I pull the disk out, it stops, which makes me think that the frickin' logic board's probably working. Oh, I gotta leave that open. Yeah, that's another thing about the... Shush! Okay, fine, turn yourself off. Jeez. That's another thing about these TRS-80 Model 4s, and I think the earlier model TRS-80s too. I'm not sure if the Model 2 is like this or not. It's like an entirely different machine, but supposedly if you start it up with the disk drive doors closed and a disk in it can erase the disk. And I did that once already off camera accidentally, so if these discs worked, they may not work anymore. I don't know. We've got the power supply out of the machine, and I cut some zip ties so I can get the AC line over here for testing purposes when we need to. But let's look at this thing a little bit and see if we can find anything untoward going on. Now, obviously at first we can see that these AC line filter capacitors here and here are in exceptionally shitty shape. I mean, that one on the bottom's already exploded. That one's got cracks all over it. There's another AC line filter capacitor right here, another big refit cap, and it doesn't have any cracks in it, but it's gonna blow up one of these days anyway. So I tell you, I've got half a notion to just pull all of those out of here before they cause trouble. They just blow up and make a big stink. Their only purpose is to comply with 1980s FCC regulations. They don't actually do anything useful. They prevent interference produced by the computer from going back out onto the AC line. And that was a thing back in the days when people actually watched broadcast television, but it isn't anymore, and I don't think maybe, I don't know if newer power supplies have all of this AC line filtering in them or not. I know newer computers don't have all of this fucking RF shielding in them, so who knows? Anyway, so we'll take those out, and just looking at the capacitors, I mean, these great big capacitors, at least in my experience, very seldom go bad. It's the itty bitty shitty ones that are always fucked up. But none of them appear to have done any leaking or bulging. I don't see any shit down on the board in there anywhere. They all look fine. At first I thought maybe this one was bulged, but it was just the way the dust was on it. But no, I think it's fine. This pin here is the 12 volt output that's not working, and that is a 1.5 amp 12 volt output. And if we can't figure out how to fix this, I have a plan to deal with that, but we'll try to fix this bad boy first. So that's the pin right there, and it goes down to this filter capacitor, and actually that capacitor is in circuit by itself, so we may be able to try to test that thing with a multimeter. I don't have an ESR meter, but you can kind of test them a little bit with an ohm meter just to see if they discharge right. Yeah, these two pins here. I probably ought to get an ESR meter, but yeah, one of these days. This is a lot easier with an analog meter than a digital meter. I don't know if we'll be able to tell anything or not, but that is a pretty big capacitor, so it'll probably take it a little bit to charge. Let's see what happens here. So did you see it flash a little bit there before it went to an open circuit? Now if we reverse our leads and discharge the capacitor through the meter, we ought to see a spike, and then it'll go to nothing. Yeah. So it looks to me, as far as I can tell, that capacitor seems to be working all right, and that's just a filter capacitor anyway. Even if that capacitor were bad, like open even, we'd still see power on this pin. It would just be really dirty. So let's see where else this goes, and if we run out of ideas doing circuit board tracing, I may just have to try to hunt down a schematic. But anyway, yes, it goes down here. That is just a empty hole. And it comes down here to this R25. Yes, R25. I'm gonna have to get a schematic. I can't tell enough with my stupid brain here. Now, you might be thinking to yourself, well, wow, that transformer looks kind of shitty there on the end. Is it burned? I don't think that's burned. I think that's just the way it was made. I think there's epoxy on top of what looks shitty, so I think it was made that way. Well, let me find a schematic, and we'll take these reefer capacitors off too, and yeah. Alright, reefer capacitors be gone. Yes, sir. Where's the other one? Right here. Oh, you nasty little thing. Get on out of here. Let's see, and the big bastard that must go is right here. I don't know if that'll come out of there or not. That one's a stanky boy. Stanky. Stanky boy. Yeah, it's coming out good. Yeah, there she is. Alright. Oh, that one's all shitty inside. The plastic case hadn't cracked yet, but oh yeah, it's got a few cracks in it. Yeah, good to have that out of there. Fuck off, reefer capacitors. Okay, so I'm too dumb to figure out how that power supply works without a schematic, and I may be too dumb to figure out how it works with a schematic. So everything other than that 12 volt CRT circuit, amp and a half, 12 volts, seem to be working. So I put it all back together, and of course I haven't fixed that CRT power supply, 12 volt power supply, but I do happen to have a Chinesium wall wart here that I pried the back off of, and have some bare wires here. So I think what I'm going to do is power this sucker up and then sneak these wires over here and insert them into this connector that goes to the that takes the CRT power supply off of the board there, and see if we finally get a raster on the screen there. I may have to adjust my pots here a little bit, but I think these wires ought to stay in this connector as they should. Alright, gentlemen and gentle unmen, we've got a raster now, so let me tell you about that. I didn't record it. I was only getting 8 volts out of that previous Chinesium transformer, so I went and got another Chinesium transformer that is outputting 12.7 volts and did the same thing with it, and it's giving me a raster now. So let's see what happens. I'm going to point it at the screen. Well, I don't know. Well, I guess if something explodes, it'll be in. You won't be able to see it anyway. So let's just point it at the screen and see what happens. Did I see some text? Oh boys. Oh boys. Check it out. It's prompting for a disk. It's prompting for a disk. So I hit the reset button, and it's okay. It's prompting for a disk again. I'm not hearing any head movement in the disk drive. So I don't think it's gonna boot. Now there's a way. What do? Hold Control Break and reset. Is that how you boot it into TRS-80 Model 3? Yeah, that's TRS-80 Model 3 mode. Well, okay, we're getting somewhere now. We've got shit on the screen, and the logic board appears to be working. We're going to have to sort out these disk drive issues. However, it is getting late, and I should go do something like play Wasteland 3 before I go to bed. Well, yeah, it seems to be working. I mean, other than the disk drives. So, yeah, cool. Alright, so that's powering the CRT off of that wall wart, though. So, I have a plan for that, but I don't have time for that this evening. So we'll finish that part of the project tomorrow. We are going to fix that power supply, but we're going to fix it in a hillbilly way. See you tomorrow, my friends.